in case of insulator, there is large difference between what is the conduction band and the valence band, between the valence band and conduction band. If there is large difference, then the electron from valence band will not jump to the conduction band. And if there is large difference, in case of insulator, there is large difference between the valence band and the conduction band, due to which the electron from conduction band, from valence band, will not jumps into conduction band. Therefore, the insulator have poor conductivity. To the next, we will discuss the semiconductor. In case of semiconductor, there is a small gap, energy gap, between the valence band and the conduction band. Therefore, some of the electron can jump and they causes conduction. Therefore, the insulator has some conductance. As we know, the energy gap is less in between the valence band and the conduction band. It means on increasing temperature, the conductance of semiconductor increases. For example, silicon and germanium are intrinsic semiconductor. It means they are intrinsic semiconductor, but it is not of any practical use because of they have low conductivity. So for that, in order to increase the conductivity of silicon and germanium, intrinsic semiconductor, we are going to add some impurity in them. And the process of adding impurity in the intrinsic semiconductor to increase their conductivity is termed as doping. Let us see what. The next one is semiconductor. In case of semiconductor, this one is conduction band and this one is valence band. This one is conduction band. What we see, it has a small energy difference. What we know, in case of semiconductor, there is a small energy difference between valence band and conduction band. Therefore, Therefore, some electron jumps from valence band to conduction band and cause conductivity. So the next, we know the energy difference between the valence band and the conduction band is small. That on giving energy, on increasing temperature, more and more the electron from valence band will jump to conduction band and the conductivity increases. The next is that on increasing temperature, the electrons from valence band jumps to conduction band, and increases conductivity. The next one, for example, we have silicon and germanium, but the conductivity of silicon and germanium is too low for practical use. What we know? But the conductivity of silicon and germanium is too low for practical use. What we do? In order to increase the conductivity of silicon and germanium, these are termed as intrinsic semiconductor. We add suitable impurity to increase their conductivity, and the process is termed as doping. We have silicon and germanium. They are termed as intrinsic semiconductor. That's in order to increase the conductivity of intrinsic semiconductor, we add suitable impurity. The process is known as doping. What we know, in case of semiconductor, there is a small gap, therefore they have poor conductance at normal temperature. But when we increase the temperature, the electron from valence band jumps to conduction band, and on increasing temperature, the conduction increases. For example, we have silicon and germanium as intrinsic semiconductor, but their conductance is too low for the practical use. In order to increase their conductivity, we add the impurity that is suitable impurity, and the process of increasing the conductivity of the intrinsic semiconductor by adding suitable impurity is termed as doping. So the next we will discuss categorize the semiconductor. Semiconductor it is categorized into two types based on their nature. The first one is termed as intrinsic semiconductor. They are pure. They conduct electricity in their pure state. They conduct electricity in pure state. Or we can say they are pure semiconductor. Intrinsic, they are pure semiconductor. To the next, we have extrinsic. Semiconductor. It is of two types. The first one is known as N-type semiconductor. And the next is known as P-type semiconductor. What is N-type? We know intrinsic semiconductor. We have the example silicon and germanium. Extrinsic semiconductor, these are the semiconductor which are formed as a result of doping. It means they have doping. On the basis of type of impurities doped, they are categorized into N-type semiconductor and the next one P-type semiconductor. As the name indicates, N-type semiconductor, it means in this type of semiconductor, the charge carrier is hole, charge carrier is electron, charge carrier is electron. In case of N-type semiconductor, the charge carrier is electron, and in case of P-type semiconductor, charge carrier is hole, or we can say vacancy of electron. Hole is positive and the electron is negative. Therefore, it is termed as N-type semiconductor and P-type semiconductor. Let us discuss how N-type semiconductor is formed and how P-type semiconductor is formed. How electron is acting as charge carrier in N-type semiconductor and how hole or the vacancy of the electron is acting as charge carrier in case of P-type semiconductor. When we are discussing the first one, N-type semiconductor, discuss the first one, N-type semiconductor. you know, the silicon and germanium belongs to 14th group of the periodic table, and they have 4 valence electron. These 4 valence electron of one atom are bond with the 4 valence electron of another atom, and therefore they have no free electron. This is the cause of having low conductivity. But when we do the impurity of 15th group of the periodic table, that is of nitrogen group, we know in case of nitrogen group it has 5 valence electron. When we add the impurity or the elements of 15th group, then in that case they undergoes bond formation. It means the 14th group element undergoes bond formation with the 15th group. Then how many bonds are formed? 4 covalent bonds are formed. On bonding 4 covalent bonds, 1 electron is free because nitrogen is pentavalent. It has 5 electrons in the outermost shell. 1 electron is free, that is responsible for increasing the conductivity of N-type semiconductor. Though electron is of negative charge, and therefore it is termed as N-type semiconductor. What happens? Let us see. In case of germanium, how many valence electrons are there? 4. Let us see. Germanium, Ge, next one, Ge, 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 what we see? We see that in the lattice of germanium, it undergoes 1, 2, it undergoes covalent bond formation. And how many valence electron it has? It belongs to 14th group. Therefore, they have what? 4 valence electrons. This is the crystal of germanium. In case of germanium, we know it has 4 valence electron. 4 valence electron. This one is 1, 2, 3, 4. This 4 valence electron, it undergoes covalent bond formation with the adjacent germanium atoms. And this is the cause of having low conductivity. But what happens? If we add a pentavalent impurities, that is an electron having 5, an atom having 5 electron in the valence shell, that is, we are going to do the element of nitrogen family. It means if we are going to do the element of having nitrogen family, then let us see what happens. This one is germanium, Ge. If we are going to do an element of, that is, an element of 15 group, that is phosphorus, arsenic, then we know it has 5 valence electron. Then how the bonding takes place, let us see. Then in that case, we have 1, 2, the entire 1, 2 electron, 1, 2 electron. They have also shared the electrons in between them. What do you see? We have a pentavalent impurity which has 5 electrons in their valence shell because it belongs to 15th group. We know it will share one of its electron with the upper germanium, one electron with this germanium, one electron with this germanium, one electron with this germanium. It means it undergoes covalent bond formation with adjacent germanium atom. How many bond electrons are engaged here? 4. A pentavalent impurity. What is left? 1 electron is left. Because it has 5 electrons in the outermost shell, that is 1, 2, 3, 4 and 5. Due to this free electron, free electron, the electrical conductance of N-type or P-type semiconductor increases on doping. Though this electron is of negative type, the charge carrier is of negative type, therefore it is termed as N-type semiconductor. Let us discuss what is happening. In case of N-type semiconductor, the intrinsic semiconductor that is silicon and germanium is duped with pentavalent impurity. That is, they are doped with